Questions? No? Okay. Last class we covered 3.3. Today we'll cover 3.3 and 3.4. Well, one, because the graphing's simple since we use Desmos, but also it's just not very long. So 3.3 is piecewise functions. That's where you have more than one function, and it all depends on if, and there'll be different inequalities. For the first one, x less than or equal to 0, this line with it means it can equal 0, where this one is only greater than 0, so it cannot equal 0. Because remember, we can't have more than one x value have two different y values, or it wouldn't be a function. So the same x value cannot equal two different values for y. So these cannot overlap. First, we're going to find some values and then we'll graph it. So when f of 1, when you're trying to find it, remember inside here is the x value. So that's what you want to look for first to see if you're using the top row or the bottom row. So if we have f of 1, notice that 1 is greater than 0. So that would use the bottom row. Trying to bring the chat up so that in case someone typed into the chat, but it just doesn't want to cooperate. There we go. So f of 1, 1 is greater than 0, so it would go into the bottom row. So we'd have 1 cubed plus 2, which is 3. And the second one, f of 0, it would not be the bottom one because that's only greater than 0, or the top one has the equal to part with it. So we would use the top row and plug in 0. 0 squared minus 1 is a negative 1. Any questions? The biggest mistakes on a test is that you forget to use this. So for -2, would we use the top row or the bottom row? And if you don't want to unmute, then just type it in the chat. So top or bottom for x equals -2. Anyone?
Is it top because the x is less than 0?
Exactly. So since -2 is less than or equal to 0, we use the top. So we have -2 squared minus 1. -2 squared is a positive 4, minus 1 is 3. Any questions on that? Okay. To graph it, we'll open Desmos. Now, when you're typing the equations and you have the inequalities, we're going to put the inequalities in what's called script parentheses. So they look like this. You won't need the if. So we first type x squared minus 1. Now, when you're doing the squared part, if you want to bring this little keyboard on the bottom up, you can, and they have a squared. Another way of doing it is the caret button. It's where your 6 is, and that will bring you up into the exponent. The only thing is you have to hit the right arrow to go back down. So it was x squared minus 1. Now the script parenthesis, that's where your square parenthesis is, right next to the letter P on your keyboard. What's nice is it puts both of them. So then we put x for less than or equal to. Those are on the keypad at the bottom, and we wanted less than or equal to 0. If you want, you can hit the right arrow and a space, and it will make the script for you. Or you hit your shift and your square bar, and it'll come up. Any questions on that? So if you noticed, before I'm going to go the other way. Before I put in the inequality, we had a parabola. Then when we put in the inequality, x less than or equal to 0, now we only have half of a parabola because we wanted everything 0 or less. So it only kept the left side and not the right side. Any questions so far? Now we do the same thing for the other equation, x cubed plus 2, x caret 3, and then remember to come back down by pushing the right arrow, plus 2. Now this is a cubic graph. It kind of looks like a snake. We want to put our script parenthesis, x greater than 0. There we go. So we can see it a little better. Any questions on the graphs?
How did you get the parentheses to look like that again?
Where your square bracket is, it's right next to the P on the keyboard. You have to hit shift and the square bracket.
Oh, okay, yeah, I see it now. Thank you.
You're welcome. Is everyone getting the graphs to look like that? When we get into limits, we'll use a lot of these graphs. And it's important to know where there's a break in the graph. So if I trace this graph from left to right, I'm following the green line, and then all of a sudden it ends and there's a break. Wherever there's a break, it's a discontinuous. And a lot of times that's where your prices increase or decrease, and you want to look for those breaks. So this would be discontinuous at x equals, and then you would put the x value, which in this case is 0. So if we trace the graph, there's a jump in the line here. It's broken. So it's discontinuous at that x value, which in this case is 0. Any questions on that? Okay. The second one, I don't know why that box is staying there, but the second one, again, we have a piecewise function. This is when x is less than 4. This is when x is greater than or equal to 4. So we want to find f of 6, f of 4, and f of negative 6. So go ahead and find those. If you do find them, type them just in that order, in the chat. You don't have to put f of 6, just put like if it's 5, 10, -2, whatever it is. Type those in. These are ones you should be able to do quickly. So you do want to get comfortable with it. For the first one, did you get -2? 6. So we compare both of these. 6 is not less than 4. 6 is greater than or equal to 4. So we use the bottom row and plug in 6 for x. 4 minus 6 is a -2. Is that what everyone got?
Yes.
The second one is a 4, so we want to see which one it falls into. Well, 4 is not less than 4, but 4 is greater than or equal to 4. So you want to, when it's the same value, look for that equal to part. In this case, it's in the bottom one. So we use the bottom. 4 minus 4, you should have gotten 0. -6. -6 is less than 4. It's not greater than or equal to. So we use the top row. -6 minus 4, -10. Any questions on getting those? Okay. Let's graph it on Desmos. There it is. I'm going to delete these two and start over. So we have x minus 4 script x less than 4. And then 4 minus x x greater than or equal to are you getting an upside down V? Any questions? Is everyone getting the graph? Notice if we trace this graph from left to right, it's continuous. At the point 4, 0, the one overlapped with the other one and made it continuous. So this would be a continuous graph because there's no break in the line. Any questions? Number 3. The formula that gives the wind chill factor for a 60-degree Fahrenheit temperature and a wind with velocity v in miles per hour is given by this. So velocity is in miles per hour, and then the wind chill. Find the wind chill factor for a 60-degree day when the wind is 20 miles per hour. Miles per hour is v. So if v is 20 miles per hour, we need to decide whether to use the top, the middle, or the bottom row. So if v is 20, would we use the top, middle, or bottom? If you don't want to say, type it in the chat. Anyone?
Is it the middle?
Yes. It's the middle because 20 is not between 0 and 4, but 20 is between 4 and 55.9. It's not greater than 55. So it falls into the middle, so we use the middle equation. 0.644 times, and we'll plug 20 in for V. Oh, 644 times. Are you getting 46.8 degrees? So on a 60-degree day, if the wind is 20 miles per hour, it's going to feel like it's about 47 degrees out. Any questions on that? I know the kids in our area, we got off one day because of the cold weather. And it wasn't that it was cold, it was that the wind made it below 0. So I think it was 7 degrees out. But then with the wind chill, it was a -10. And so they called off school. So the wind chill does make a big difference. And this is a formula they would use on a 60-degree day. Any questions? Okay, find the wind chill factor for a 60-degree temperature if the wind is 65 miles per hour. So at 65 miles per hour, we need to decide which row to use and then plug it into the equation. So at 65 miles per hour, would we use the top, the middle, or the bottom? Anyone? See where 65 falls. It's not between 0 and 4. It's not between 4 and 55.9, but 65 is greater than 55.9. So it falls in the bottom. And anything above 55.9, the temperature will feel like 41 degrees. So when the weatherman gives a certain temperature and says, but it feels like, that's because there's high winds and they're finding out. That's a big drop, almost 20 degrees. Any questions on that? Okay, let's try another. Number 4, we need to set the equation up. For the non-extreme weather months, the electric company charges $7.10 plus 6.747 cents per kilowatt hour for customers using up to 1,200 kilowatt hours, and charges $88.06 plus 5.788 cents per kilowatt hour above 1,200 kilowatt hours. So you can see how they broke that up, kind of like our inequalities. Up to 1,200, which would mean less than or equal to, or above 1,200. So those are our two inequalities. Write a function that gives the monthly charge in dollars. So cost equals, the first one says $7.10 plus, and then it gives us the pennies per kilowatt hour. Remember, an equation, y equals mx plus b. $7.10, that's the fixed cost. This one is the rate because it's per kilowatt hours. Per means multiply. But this is in pennies, so we need to make it dollars. That's 0.06747 x plus the fixed cost, $7.10. So it's $7.10 plus this change times your kilowatt hours. And that is if x is up to 1,200, so less than or equal to 1,200. X is kilowatt hours and cost is in dollars. Any questions on the first row? The second one is $88.06 plus 5.788 cents per kilowatt hour. So this is the one again, per means multiply. This gets multiplied times your X. It's a rate. But this is in cents. We need to change it to dollars. 0.05788x plus the $88.06. And that's if X is above 1,200. Any questions on setting it up? So it's just setting our equations up a step further. Any questions? What is the monthly charge if 960 kilowatt hours are used? Well, if 960 kilowatt hours are used, 900, that would be in this one because 960 is less than or equal to 1,200. So that would use the first row. So then we just plug it in. And calculate it. $71.87. Any questions? No. Okay, Go ahead and find the monthly charge if it's 1,580 kilowatt hours. So for 1,580 is greater than 1,200. So it uses the bottom row. Laying it in, are you getting $179.51? Any questions on those? Section 3.4. Deals with a few different equations and knowing what they look like. So just as a refresher, linear equation is y equals mx plus b. And we also used quadratic. Remember, that's our parabola. It's y equals ax squared plus bx plus c. Now this also introduces a power function in this section, and then we deal more with it the next chapter. But the power function is y equals ax to the b. What happens is it just grows really fast up or down. And so that's what this equation looks like. When A is going up, when A is greater than 1, it goes up really quick, the absolute value. When the absolute value of A is between 0 and 1, it goes down. And so when we do this table, instead of just having the linear regression line, now we'll have a quadratic and a power and see which one fits the best. And so we're going to graph a little bit differently than we were before. I'll bring this over here. Wait, I need Desmos. There it is. So we'll delete what we had. Now, another way of entering a table instead of going to the statistics, because that one only gives the straight line. If we go here, so just click that little plus sign and go to table, you can enter a table. Where you need to be careful when we're doing equations, notice it says x1 and y1. You have to use x1 and y1. I tried to get rid of the ones and it wouldn't work. It has to keep the ones. So we will use the first box and we're going to do these steps. We're going to make a scatter plot of the data. So just enter 3, 5, 7, 9. 3, 5, 7, 9. Oops, didn't hit enter. 3, 5, 7, 9. and then 4.7, 8.6, 13, and 17. Of course, we need to adjust our window. So we'll go over to here, and I'm going to go from -1 to my highest number for X is a 9, so I'm going to go to 12. And then again, Y, I'm going to go -1. And my largest is a 17, so I'm going to go to 20. But anything that's below your lowest and above your highest will show all of your points. It should show all of your points. Maybe I didn't hit a number right. 12, -1, -1. Oh, I put 10 instead of 20. There we go. It looks pretty close to a straight line. But it also could look like a parabola. If this came down and then went around and up, could be a parabola. And then the exponential goes across and then up. Okay, to see which one's the best, you click, see the number 2? If we click here, because it says part B says linear function. Everyone has the graph. Is there any questions on the graph? So to get this, I just clicked on the plus and went to table. Now to do an equation, we first put y1. Now, what you need is, it's a little, you know how the little squiggly line? It's right to it's the top left on your keypad. It's where the apostrophe is at the top. Looks like that. So remember when we had the Excel, not the Excel, the trend line, when it gave us it earlier, it put this little squiggly line. But you make sure you do y1. Now, if we're going to do the x, the linear one, remember that's mx. We have to do x1 plus b. Because it's straight line, mx plus b. You have to put the ones, though, because that's what these have. So then this is our equation. So if we wrote the linear equation, y equals m is 2.065, x, and b is a negative 1.565. And the r squared, 0.9995. And if you look, it is really close. This one's off a little bit, and this one's off a little bit, but they're pretty darn close. So that would be a linear model. Any questions on that? Okay, to do, I forget what I put next, but doesn't matter. Okay, so the power function. To do the power function, we do y1, and then on the top left, the little wavy line. Now a power function, ax to the b, and you'll have to put x1. So ax1, and then a caret gets you to the exponent, and put b. And then you can use the right arrow to come back down. So this would be your power function. Y equals A is, I'm going to go 1 decimal place. So A is 1.3x, and then my exponent is 1.2. And R squared, 0.9992. So this one is, I mean, they're both really strong because it's almost 1. But this one's a little bit less accurate than this one. So if you were going to a further value extrapolation, this would be more accurate. For the quadratic, remember that's ax squared plus bx plus c. So then we do the same thing on the fourth line. Y1 with the little squiggly line. And then it's ax squared. So you can do the caret 2 and come back down. Plus bx 1. Oh, I forgot the 1 on the last one. bx1 plus c. And make sure you remember the 1s. And then here's our value, and notice the r squared is same as the linear. That's because they made a so small. Y equals 0.00625. X squared plus 1.99x minus 1.37125. And r squared is the 0.9995. So all of them are really strong. Depending on what you would want, they would all work. Now to see the graph, let me make this a little bit bigger. I shrunk it so that you could see the green is a parabola. The blue is a power function. Now the reason you're not seeing the whole line, it does keep going. This should keep at 0, go across. I don't know why it's not doing it. For some reason it's stopping at 0. Yeah. Is there any questions on it? We're going to do another one. Now, what's nice about the next one, leave these here, because as we change the table, it will change these. So if we look at our next one and go up to your table, delete the 3. So we want 1 through 6. 1, 2, 3, 4, 5, 6. And my values 4, 9, 11, 21, 32, and 45. You can see the green is your parabola, the straight line, exponential function. But if you look at the R's, they did change. Any questions on that? So our linear would be here. See, and that's 0.93 0.88. And this one's 0.986, so this one's a little stronger than the linear. 9866. This one's 99, so the parabola is the most accurate in this one. Is there any questions on that? Any questions? Okay. Try a story problem. Page 227, number 31. Okay, so number 31 states, partially because of Americans living longer, the number with Alzheimer's disease and other dementia is projected to grow each year. The table below gives the millions of U.S. citizens with Alzheimer's from 2000 and projected to 2050. Create the scatter plot of the data with X equal to the number of years after 2000 and Y equal to the number of millions of Americans with Alzheimer's disease or dementia. So X is the number of years after 2000. So when we go to graph it, the first one is 2000 for the year. X is the number of years after 2000. Well, that would be 0. That's our starting point. The next one is 2010. That would be 10 years after 2000. So you're just subtracting 2000. So this would be 10. The next one is 20, because it's 20 years after. And then 30, 40, and 50. And then go in and change your Y values. 4.0, 5.9, 6.8, 8.7, 11.8, and 14.3. Any questions on the scatter plot? I'm going to adjust the window so you can see them all. So I'm going to go from -1, and it goes up to 50, so I'm going to go 60. And then the Y, -1, and then it goes up to 14, so I'm going to do 18. Yeah. Any questions on the graph or the scatter plot? And the Y values are already there for our linear, our power, and our quadratic. If we look at the R squareds, notice the parabola is 0.99. If we look at the other two, well, especially the exponential, it's definitely not an exponential because that one's 0.74. And this one's 0.97, but the quadratic is definitely the stronger of the three. Any questions on that? Okay, part B says to find a quadratic function that models this data, which is what we did right here. So y equals a, which is 0.002. Now, on MyLabs, make sure you round to whatever they say. So ax squared plus 0.098 x plus 4.0 207. I went 3 decimal places. Oops, I didn't. I'll bring it up in a second. Is there any questions on getting it from here? So this is our equation. Any questions? It already graphed the data and it does it together. That's the nice thing about Desmos. How many Americans does the model predict will have Alzheimer's disease or dementia in 2056? Well, this is a year. X is the number of years after 2000. It is not what year it is. So you need to be careful and subtract the 2000. So X is 56. Then we put 56 in. Remember, this would be an extrapolation because 2056 is beyond the values they use. Anything between 2000 and 2050 would be interpolation. Two. So you should be getting 15.967 million Americans. Is there any questions on that? Positive. Any questions on using Desmos?